Hello guys, welcome to my channel Knowledge Unlimited. In this video, I'm going to explain one more interesting example question. So the question is, what's the maximum operational frequency of the circuit given? And here you can see there are three flip-flops, flip-flop 1, flip-flop 2 and flip-flop 3, each having a setup time, hold time and a clock to Q delay, same 2 and here 3. So the question is, what's the maximum operational frequency? Now here, unlike other questions where we have solved only with two flops, here you need to analyze the path between this one for flip-flop 1 and flip-flop 2 as well as flip-flop 2 and flip-flop 3. This is the second path. So I have pre-drawn the clock waveforms and all to make the video length as small as possible. But let me explain the question. So here you can see there is a combinational logic delay between flip-flop 1 and flip-flop 2, that is D1, and from flip-flop 2 to flip-flop 3, that is D2. The delays are given as D1 and D2. And the clock having a skew or a delay in the clock path you can call S1 here from flip-flop 1 to flip-flop 2. So for flop 1, the clock is going without any delay, but for flop 2, it's going with a delay of S1, skew 1 or S1 delay, and from flop 2, it's going with a delay of S2 to flop 3. So from here, if you see, it's like S1 plus S2, but from point 2, it's like just S2 delay. So the question to calculate all that, first let's interpret what the clock waveforms look like. So the clock 1 is the waveform that is going to flop 1, that is the first waveform, and the second waveform having a delay of S1. So this waveform is shifted by S1 delay, that is this clock 2, that is at this node 2, and this third clock is shifted from the second node S2, the S2 delay we are adding here. So it's like total S1 plus S2 compared to first waveform. From the second waveform, it's just S2. So far, I think you are clear. Now, you guys know, right? The setup time equation is only needed to find the maximum operational frequency or the clock period that is required. And let's brush up the basics one more time. This is called as the clock period. And setup time is the minimum time ahead of this clock pulse or clock edge, the data should become stable. So that's called as setup time. And now in this time frame, you need to accommodate all the delays here so that your clock to Q delay might be some delay, and then your combo logic delay and the setup time of second flop. So this in the entire one clock period, you need to accommodate all these three delays. From there, where you will get the setup time equation. If you look here, from this clock edge to this edge is what our new window is, because there is a delay of S1 that we are adding here. This delay is S1. So this entire area you have now. So what this is called as T clock plus this S1 should be always greater than or equal to, writing is a little bad, greater than or equal to this delay. So that is T clock to Q1 plus D1 plus setup time of second flop, that is T setup time 2. So this is your first flip-flop 1 to flip-flop 2 equation. So if I bring this here, T clock should be greater than or equal to T CQ1 plus D1 plus T SU2 minus S1 delay. So this is your first equation. Okay. Now the same will hold for flop 2 to flop 3 as well. And now here you can see same. The clock period will be same here, T clock. But here from here you are considering, right? So it will be just S2 addition. So it's like T clock plus S2 should be greater than or equal to, from here to here it is now. So T clock to Q delay of second flop plus D2. So this one you need to write plus setup time of flip-flop 3, T setup time of 3. So T clock should be greater than or equal to T CQ2 plus D2 plus T setup time 3 minus S2. So this is your second equation. So you have two possible equations here for T clock, and that is from flip-flop 1 to flip-flop 2 and flip-flop 2 to flip-flop 3. From these two equations, the question is, what's the maximum operational frequency, which is nothing but minimum time period. Now let's give a simple example here. Let's say if you add the numericals, you got this as 5 nanoseconds. You got here as 7 nanoseconds. Just a rough example. Now you think in general what should be the generic equation here is. So let's say your time period you are deciding as 5 nanoseconds. Then because here the requirement is 7 nanoseconds, you might face a setup time violations here. But let's say if you take it as 7 nanoseconds, then this path you have little area here available to accommodate some logic, but still you won't get any violations here. So simply the generic equation is your clock period should be always greater than or equal to max of this equation T1 and T2, this T1 and this T2. So among this, whatever the max is your clock period. So when you get the minimum clock period, the maximum frequency should be Fmax equal to 1 by Tmin. So in this way, you can solve any question, provided they will add numericals here. You can simply substitute the values, or from here itself you can substitute the values and get to the right answer. Hope you guys learned something new in this video. Subscribe and watch out for more videos.